Hello students, welcome back to my channel. This is Ma'am Tin. For today's lecture, this is all about experimental designs for pre-college research. You don't make a dress without a design. You don't cook food without a recipe. You don't make a building without a blueprint. In short, you don't experiment without an experimental design. Why is there a need for an experimental design? So we need to consider three reasons for that. Number one, cost-effective collection of appropriate data. Another, we have appropriate and valid analysis of data and valid conclusions. Okay, here are some types of experimental design. So let's start with the CRD, or it is known as the completely randomized design. So this is one where the treatments are assigned completely at random so that each experimental unit has the same chance of receiving any one treatment. Now CRD is best suited for experiments with small number of treatments. Okay, so we have here an example of an experiment showing how completely randomized design is being applied. So given the example, effect of fertilizer to the growth of tomato plant. Now in the CRD, we need to consider the process of the randomization. So these are the following procedures. So we need to assign, okay, treatments are assigned to experimental units completely at random. And every experimental unit has the same probability of receiving any treatment, and randomization is performed using a random table, computer, program, or etc. So given this example, we have the following treatments. We have treatment 0, no fertilizer. We have treatment 1, medium fertilizer, and we have treatment 2, we have a lot of fertilizer. So in terms of the experimental units, so our experimental units are tomato plants. So let's say we have 9 tomato plants all in this experiment. So tomato plant 1, 2, and 3 will assign to receive no fertilizer. Tomatoes 4, 5, and 6 for treatment 1 having medium fertilizer, and for tomatoes 7, 8, and 9 will receive treatment 2, means a lot of fertilizer. Okay, another type of experimental design is we have the RCBD, so the randomized complete block design, and this one is more common or most common or a standard design for agricultural experiments in which similar experimental units are grouped into blocks or replicates. So it is used to control variations in an experiment by, or for example, accounting for the spatial effects in fields of greenhouse. The third one is we have the Latin square design, and this is all about the experimental material is divided into M rows, M columns, and M treatments. Okay, so what are treatments? So treatment or factor. So these are the conditions whose effects are to be measured and compared. And we have also the term response variable. So this is all about the characteristic used to measure the effect of a treatment. So experimental unit. Unit to which a single treatment is applied. And we have the experimental error. Failure of two experimental units treated alike to yield the same. So given the example, we have chicken manure as crab feeds. So we have case 1 and case 2. So in case 1, crab is our experimental unit, and in case 2, each aquarium is an experimental unit. Now again, when we say experimental unit, this is a unit to which a single treatment is applied. We have the term replication. So replication refers to the number of times a treatment level appears in the experiment. How many times? Next, we have when we say level, okay, level refers to the preset quantity of a treatment, and we need to lay out our treatment, or this is considered to be the final arrangement of the treatment levels. So given this example, again, chicken manure as grab feed. So we have three levels. So level 1, we have the use of the commercial feed. Level 2, the use of manure from conventional grown chickens. And level 3 means we have manure from organically grown chickens. So level means treatment. So how are we going to lay out our level or treatment? Okay, so if we're going to lay out our level of treatment, so treatments must be written on the left side, and here our replicates. So the number of times that we're going to test this one to our experimental unit. Now, if you are asked chicken manure as crab feeds, so our experimental unit is the crab. Now, what are the levels or the treatments? So we have the commercial feeds, we have the manure from organically grown chicken, and we have the manure from conventionally grown chickens. So how many experimental units if we are going to test this one 3 times and having 1 crab per treatment? So we need at least 9 crabs all in all. So we need 3 crabs per treatment. So every crab is considered to be our experimental unit. So we have 9 experimental units all in all. Let's say if I have 5 treatments with 3 replicates each. So how many crabs do I need given this experimental unit? So let's say 1 crab per replicate. And we need to test this one for 3 times. So 5 treatments times 3 replicates. So we need 15 crabs all in all. Okay, thank you for watching. Don't forget to like, share, and subscribe to my channel.